This chapter summarizes the major concepts discussed throughout the study of living in zero gravity, and emphasizes the significance of continued research in this field. It explains how understanding the effects of microgravity on humans, plants, animals, and technology contributes to safer and more successful space exploration missions. The chapter highlights the practical benefits of space research, including advances in medicine, engineering, materials science, communication technologies, environmental monitoring, and disaster management that improve life on Earth. It also discusses the importance of international cooperation, scientific innovation, and responsible exploration as humanity prepares for future missions to the Moon, Mars, and beyond. The chapter concludes by emphasizing that studying life in zero gravity not only expands our knowledge of the universe, but also inspires future generations to pursue scientific discovery and contribute to humanity's ongoing exploration of space. This chapter discusses the future possibilities of human life beyond Earth and examines how advances in science and technology may allow people to establish permanent communities in space. It explores current plans for building lunar bases, sending astronauts to Mars, constructing commercial space stations, and developing space tourism. The chapter explains how future space habitats may include artificial gravity systems, advanced life support technologies, sustainable food production through space agriculture, and closed-loop recycling systems that allow people to live independently for long periods. It also discusses the role of private space companies and international partnerships in expanding human presence beyond Earth. Finally, the chapter examines the scientific, economic, and social benefits of becoming a spacefaring civilization, while addressing the ethical and environmental challenges associated with human expansion into space. This chapter examines the numerous challenges and dangers associated with living in zero gravity and conducting long-term space missions. It explains how astronauts face constant exposure to cosmic radiation, which increases the risk of cancer and other health problems because space lacks Earth's protective atmosphere and magnetic field. The chapter also discusses the dangers posed by space debris, equipment failures, fires, air leaks, and limited emergency rescue options. It explains how astronauts must carefully manage limited supplies of food, water, fuel, and oxygen, while maintaining the spacecraft's complex systems. In addition, the chapter describes the emotional and psychological challenges caused by isolation, confinement, communication delays, and the stress of working in a dangerous environment. It concludes by explaining how careful planning, intensive training, advanced engineering, and international cooperation help reduce these risks and improve mission safety. This chapter explains the advanced technologies that make it possible for humans to survive and work safely in the harsh environment of space. It describes the design and operation of spacecraft, space stations, life support systems, and spacesuits that provide oxygen, regulate temperature, remove carbon dioxide, and protect astronauts from radiation and extreme temperatures. The chapter also explains how air and water recycling systems conserve valuable resources by purifying water and continuously recycling breathable air. It discusses the role of robotics, artificial intelligence, computers, communication systems, and scientific instruments in assisting astronauts with research and maintenance tasks. Furthermore, the chapter examines docking systems, power generation through solar panels, emergency safety equipment, and future technological innovations that will support permanent human settlements on the Moon and Mars. This chapter explores the many physical and psychological effects that living in zero gravity has on the human body. It explains how the absence of gravity causes muscles to weaken because they no longer need to support body weight, while bones gradually lose minerals and become less dense, increasing the risk of fractures after returning to Earth. The chapter also discusses fluid shifts toward the upper body, changes in blood circulation, balance problems, vision changes, and the effects on the cardiovascular and immune systems. It explains how astronauts often experience space motion sickness during the first few days of a mission as their bodies adapt to the new environment. In addition, the chapter examines the psychological challenges of isolation, confinement, stress, and separation from family and friends during long-duration missions. Finally, it explains the countermeasures used to protect astronauts' health, including daily exercise programs, balanced nutrition, medical monitoring, mental health support, and ongoing scientific research. This chapter provides a detailed description of how astronauts perform everyday activities while living in space. It explains how simple tasks such as eating, drinking, sleeping, brushing teeth, taking showers, dressing, and using the restroom become much more complicated in a weightless environment. The chapter describes how astronauts consume specially prepared foods, drink liquids from sealed containers, and sleep inside sleeping bags attached to the walls of the spacecraft to prevent themselves from floating away. It also discusses how they maintain personal hygiene using rinseless soaps and special cleaning products because water does not flow normally in zero gravity. Furthermore, the chapter explains the importance of daily exercise to maintain muscle strength and bone density, and describes the specialized equipment used aboard the International Space Station. It also examines astronauts' work schedules, scientific experiments, communication with mission control, teamwork, recreation, and methods for maintaining mental well-being during long missions. This chapter explains the scientific principles behind zero gravity in greater detail. It begins by describing gravity as the natural force that attracts all objects toward one another, and explains how Earth's gravity keeps people, oceans, and the atmosphere on the planet's surface. The chapter discusses Newton's law of universal gravitation and explains how spacecraft remain in orbit by constantly moving forward while simultaneously falling toward Earth. It clarifies the difference between true zero gravity, which exists only in deep space far from massive objects, and microgravity, the condition experienced by astronauts in orbit. The chapter also introduces the concept of artificial gravity, explaining how rotating spacecraft or space habitats could create a gravity-like force through centrifugal motion. Finally, it discusses how scientists use zero-gravity environments to conduct experiments in physics, biology, chemistry, medicine, and materials science that cannot be performed under Earth's normal gravitational conditions. This chapter introduces the concept of living in zero gravity and explains why it has become one of the most important areas of modern space science. It describes zero gravity, also known as microgravity, as the condition in which people and objects appear to float because they are in continuous free fall while orbiting the Earth. The chapter explains that astronauts do not completely escape Earth's gravity. Instead, they experience weightlessness because their spacecraft and everything inside it are falling around the Earth at the same speed. It also discusses the history of space exploration, beginning with the first human spaceflights and continuing through the development of modern space stations, such as the International Space Station, ISS. Furthermore, the chapter explains why scientists study the effects of zero gravity on the human body, plants, animals, and technology. It highlights the importance of this research for preparing astronauts for future long-duration missions to the Moon, Mars, and beyond, while also improving scientific knowledge and technological innovations that benefit life on Earth.